Hello and welcome to IGCSE Tube. So this is part number 9 of chapter number 14, Organic Chemistry. In this video, I will be talking about addition polymerization of alkenes. If you have watched part number 6, it is the part where I introduce what alkenes are. In part number 7, I talk about the manufacture of alkenes by cracking. In part number 8, I talk about how to distinguish between saturation and unsaturation. And I list the different reactions that alkenes can undergo, and I also talk about the combustion of alkenes. So the part we're covering in this video is in section 14.5 in the syllabus. As I always say, the URL of the syllabus is in the description box below. Please make sure to go and have a look at it. So in this video, we'll be describing the formation of polyethene as an example of addition polymerization of monomer units. Okay, let's get started. So what is addition polymerization? Addition polymerization is basically joining small, unsaturated, because the unsaturation comes from the double bond of the alkenes, identical monomers to form large saturated polymer by heat and catalyst. So heat and catalyst are the conditions. So what is a monomer or what is a mer? Monomer or a mer, they're the same, they're synonyms. Mer is the repeating structural unit of a polymer. So when you have like a unit, which is known as the mer, when you join many mers together, it forms a polymer. That's why here it's called monomer. It's just one mer. And then a polymer is basically polymers. It's multiple mers joined together. They're small, unsaturated, identical, and they turn to large saturated polymer, like a one big unit. So here's how we present or like this reaction, the addition polymerization. So here we have ethene gas. This is the structural formula. I talk about the structural formulas in an earlier video of chapter number 14. So here's the ethene, and what's really significant is the double bond. Of course, it is reactive because it's unsaturated, and you can break this bond to make it saturated. So the conditions are, we said heat, which is 100 degrees Celsius, and the catalysts are pressure, which is 100 atmospheric pressure, and traces of air. So it turns here to polyethene. You put the ethene between brackets. That's how you present the polymer to the name of the polymer. So you write poly and then between brackets ethene. It's a solid, so it turned from a gas to a solid, and now it is unreactive because it is saturated. So as you can see here, the bond has been broken. So here's a single bond, okay, and then you extend the arms. This is how you present it. It's really important to know how you present a polymer, and then you put solid brackets, and then N here signifies that it's multiple mers joined together. So it could be 100, it could be 20, 30, 50, whatever. So this is a number here to signify that many mers are joined together. This is really fairly easy. The addition polymerization, it's a reaction that alkenes can undergo. Before I end this video, I want to talk about the uses of ethene. So as I have just discussed, it is used to manufacture polyethene. It is used to manufacture ethanol, which is a type of an alcohol, which I'll be talking about this reaction in a later video. It is also used to manufacture dry clean liquid, which is, the liquids are used for dry clean, like it's a detergent. And the one used for this specifically is dichloroethane. It's used to manufacture, ethene is used to manufacture dichloroethane. And finally, it's used to manufacture fuel as well. So this is really just an example of the multiple uses of ethene and how it's really a useful hydrocarbon. So I think I'm going to end the video here. In part number 10, I'll be talking about the addition reactions of alkenes, which is water and hydrogen, steam, hydrogen and halogens. Thank you very much for watching. If you like this video, please give it a thumbs up, and if you haven't subscribed yet, please subscribe and leave your comments in the comment section below. Thank you, and see you in the next video.